What's happening, y'all? I just wanted to run through another one of these Catriona Ags geometry puzzles because I think they're really cool. This one, the purpose is to find the blue area. And the information that we're given is that the largest of the two equilateral triangles has an area of 8. So we're looking for the blue area. So I guess the first question is, which one of these triangles is the larger one? We've got the black triangle and we've got the dark navy blue triangle. Both are equilateral triangles, so all the sides are the same in each triangle. And the black one we can tell is bigger because the blue one is fitting inside of it, right? This blue side stretches from the top of the black triangle to the bottom of the black triangle, and this black side is outside of the blue triangle. So the black one is definitely larger, so we know that that has an area of 8, the black one. If we're talking about area, we might as well have the equation for the area of a triangle, which is area equals 1/2 base times height, right? So any of these black sides in the black triangle could be a base. Why don't we draw a height on there? I'll draw that in green. So heights always make a 90-degree angle with the base, and now we've got our base and our height for the black triangle. Well, if we're going to compare that eventually to the area of the blue triangle, which is what we're looking for, we might as well draw a height on that triangle as well. If we're doing that, we might as well pick a base for the triangle. And I think a reasonable base would be one of the black sides, right? Because we know the area of the black triangle. So we know some information about that. So if we can use a black side as the base of this triangle, that's going to be helpful. Obtuse triangles are kind of tricky because when you use a base that isn't the longest side of an obtuse triangle, the height actually falls outside of the triangle. So I'm going to draw that in. Again, a height always has to make a 90-degree angle. And if we go from this point over here, we can't draw a 90-degree angle to the actual base. So we have to extend the base outside and then draw the height like this. Pretend that's a straight line for me for a second. So this is pretty interesting. So we've got bases that are the same. So if I say the base of, I'll just say the red triangle because I'm drawing this one in red. And then we've got the base of the green triangle, which is actually the black equilateral triangle. We'll call that base green. But we know that these values are exactly the same because they're both sides of the black equilateral triangle. So BG is going to equal BR. So then it becomes sort of interesting to compare the height, this green height, to the red height. Is there a way that we can prove that they were the same? Because if they were the same, if the base and the height were the same, then we would get the same area, because that's the only thing involved in the area equation. So in order to consider that, we should probably consider these two triangles. So I sort of have a red triangle that has a hypotenuse that is a blue side, and the green triangle, so if I extend this right here and make this a green triangle, the green triangle also has a blue side as a hypotenuse, which is interesting, because these triangles are starting to look pretty similar to each other. But is there a way that we can prove their congruence? Because if we can prove their congruence, then we'll be able to prove that the heights are the same. And if the heights are the same, then they have the same area. I'm going to bust this one open for you and tell you that they do have the same area. And we're going to prove how right now. All right, so now we're going to start talking about angles, because in order to prove triangle congruence, if you only have one side, you're going to need some help from angles. And all we have right now are these blue sides to compare, and they definitely have the same value. But if we can find the two angles on both sides of that and prove that they're congruent, then we will be able to prove the triangles are congruent. So one thing that we know about equilateral triangles is that all of the angles in an equilateral triangle are 60 degrees. And that's because all of the angles add up to 180. And if all of the angles are the same because all the sides are the same, then 180 divided by 3 is 60 degrees. So let's take a look at this angle in particular on the blue triangle. That's going to be 60. And this angle down here in the black triangle, that's going to be 60. And then we have some interesting triangle relationships and also angle relationships on a line. So we've got these two 60-degree angles. You might be wondering what those have to do with anything. Well, if I go right here from the blue to the black line, that's an angle that's used in a couple different ways. Because this is a line right here, And lines have angles that add up to 180. So if I draw in an angle right there, this plus the 60 plus this have to equal 180. And also this angle has a relationship in a triangle that shares this 60-degree angle with this right here. And these two angles are the angles that we're trying to prove are equal to each other. They could prove that these triangles are congruent. So if we call this one y maybe, this one z, and this one x, we can make two different equations that use this information that are going to look really similar to each other. So here, x plus y plus 60 is going to have to equal 180 because they're on the same line. And we also know that x plus z plus 60 has to equal 180 because they're in the same triangle. And that's really interesting because all of the elements of these equations are the same, so we can actually, all of this stuff is exactly the same, and if all of that stuff is exactly the same, then y and z have to be equal to each other. And if y and z are equal to each other, we're making some serious progress. So now we've proved that y and z are equal to each other, so I'm just going to call this z y because they are the same thing. And if we can prove that this angle is equal to this angle, we're going to have two congruent triangles here. And these two triangles have to have the same angles because they have two of the same angles, and they all have to add up to 180. So if y and y are the same, which they obviously are, this angle has to be the same as this angle. Now we've got two congruent triangles, and if we have two congruent triangles, then HR has to equal HG. And if HR equals HG and BG equals BR, then the areas are the same. So the answer to the question is the area of the blue area, a little repetitive there, is 8. And that'll do it for this one. Case cracked. Thanks for watching. Catch you later.